Hello everyone, my name is Aldrich. I'm from the Human-Centered Computing Department at Monash University. Today, I will be presenting work in collaboration with my supervisors on investigating the effect of directions on the limits of haptic retargeting. With the advances in immersion of VR to high-resolution visual and audio cues, the same immersion is expected of other sensory cues to maintain or even improve this immersion. Our work focuses on the haptics experience in VR. While visual and audio stimuli are sufficient to create an immersive virtual environment, this immersion easily breaks once the user tries to interact within the virtual environment without haptic feedback. Many works have been done to develop a better haptic experience in VR. In general, there are two approaches to providing haptics. These are known as active haptics and passive haptics. Active haptics pursue to accurately generating the property of an object through created devices. For example, its weight, texture, and temperature. These devices are usually handheld, grounded, or wearable. Each device is designed to provide only specific haptic properties, such as tactile feedback, force feedback, or texture. Also, this feedback is typically applied to a certain part of the body, such as the index finger, and it's difficult to build one-size-fits-all haptic devices. As a result, these devices are more compelling when used in a specialized domain and use cases. Passive haptics is another approach to providing haptics. To provide haptic feedback here, we can use passive physical objects to represent the haptic properties of virtual objects. Thus, the ability to play around with the object and directly feel its haptic properties without holding or wearing additional devices leads more towards an everyday life-like experiences. Prior works have shown that this approach improves the VR experience, primarily to increasing the sense of presence and realism of interactions. While it may be seen as a cheap approach to providing haptic feedback, can we say the same when we have many virtual objects in VR? Doesn't mean we need to physically replicate the entire virtual environment setup. These two questions raise issues regarding the flexibility and efficiency of adopting passive haptics. So, how can we get the benefits of passive haptics without a one-to-one mapping between the physical and virtual environment? Researchers recently explored the use of perceptual illusions to resolve just that. This is called haptic retargeting, a solution that remaps a physical object to multiple virtual objects. The solution is achievable by applying hand redirection, and here, the technique gradually decouples the virtual hand from the physical hand over the course of a reach. Thus, at the end of the reach, the user will see that they touch the virtual object and feel haptic feedback of the physical object. As the technique draws on visual dominance over other sensory information, the user will compensate for the offset introduced to the hand, thus allowing a successful mapping of misaligned objects. To implement hand redirection gradually, we can apply rotation-based and gain-based hand redirection. Rotation-based redirection rotates the direction of movement, allowing the remapping of a physical object to virtual counterparts on the left, right, above, or underneath. While gain-based redirection scales the movement to remap a physical object to virtual counterparts farther or closer from it. Under a certain threshold, the users won't be able to detect the offset applied by both techniques due to the brain prioritizing our visual information over other senses. This, however, comes with a limit. A large mismatch between visual and other sensory information, such as proprioception, can still be perceivable and disruptive. So the question is, to what extent can a physical object be remapped with haptic retargeting without being intrusive to the user experience? Prior works have explored the limits of gain-based redirection for reaching across the different axes. Thus, we now know how far or close a physical object can be remapped without being detected when reaching is performed on each axis. The same limits have also been explored for rotation-based redirection when reaching forward. With the known limits, we can estimate how far a physical object can be remapped with haptic retargeting. However, the known limits of haptic retargeting is incomplete, as it has been mainly explored in one primary direction, which is the user reaching forward. But we can't expect interaction across an immersive virtual environment to be limited to just forward reaches. So, does the proposed haptic retargeting limits applicable across different directions? You might ask why we care about the effect on directions. This is because haptic retargeting leverages visual dominance over proprioception. And while we already know that visual and proprioception information are not weighted evenly, the relative weighting of each sensory information changes across the interaction space. As explored by the literature around psychology and rubber hand illusion, our perception towards visual proprioceptive mismatch is influenced by where our hand is across the space. Moreover, the accuracy of each sensory modality is affected by various factors. For example, for right-handed users, reaching around the right-hand space is more susceptible to illusions. Another example is users are less susceptible to illusions closer to the body due to better proprioceptive acuity. This motivates us to look into investigating the effect of direction on haptic retargeting limits, so that we know how to use haptic retargeting across the interaction space without compromising the user experience. We derived our hypothesis based on what was known in the psychology and rubber hand illusion literature. Our first and main hypothesis is designed because the brain processes multisensory information differently depending on spatial position and direction. Thus, we hypothesize that the detection of redirection differs depending on the reach direction. We tested more hypotheses which are discussed in more detail in the paper. So, to investigate this hypothesis, we ran a user study where participants will be performing reaches with haptic retargeting towards 8 different directions on the horizontal plane. In each reaching direction, we investigate the application of rotation-based hand redirection, where a virtual hand is displaced in a clockwise or counterclockwise direction over the course of a reach, with different magnitudes tested up to 30 degrees offset. At the end of the reach, the user will be asked whether they detected an offset. Their collected responses from this task are then fed into a psychometric curve to look into the probability of participants detecting redirection across different hypotheses and reach direction. Overall, we see that the user can approximately be redirected up to 14.84 degrees depending on the reaching direction. If they detected an offset, we also measure the user's sense of body ownership with a self-localization task. This also helps indicate the perceived magnitude of redirection. The user will be responding by moving the hand seen towards the perceived position by using a controller that they held with the other hand. To give an overview of the body ownership results, we found body ownership towards the redirected virtual hand remains strong until 18-degree redirection. We discuss our results in more detail in our paper. More importantly, through the study, our work adds to the literature and completes the potential space of haptic retargeting. The following figure shows a top-down view of the limits of haptic retargeting when performing 30 cm reaches with right hand across different directions. We use our estimated limits of rotation-based redirection together with Esmaili et al.'s game-made redirection limits to map the area physical objects can be remapped to. Each arrow in the figure shows the reaching direction performed. As we see here, the remapping area of each physical object is dependent on the reach origin point, reaching distance, and direction. Moreover, the orientation of the area also differs depending on the reach direction. In summary, our work shows an investigation of the limits of haptic retargeting across the interaction space. And to the best of our knowledge, our work is the first that shows haptic retargeting works in a range of reaching direction, including reaching forward, backwards, sideways, and diagonally. We found that reaching direction affects the detection of hand redirection, but not towards the body ownership illusion. We also found that body ownership of a redirected virtual hand remains just as strong when applied within or close to the proposed detection threshold. However, while we do find an effect of reaching direction, we didn't find a strong effect as suggested by literature for haptic retargeting applications. As haptic retargeting is mainly applied within the user's switching space, The size of remapping is mainly similar across region directions. Thus, we suggest applying a conservative and consistent haptic retargeting limit across the region space. While we complete the knowledge of haptic retargeting across the interaction space, there are many other impacts that will affect the limits of haptic retargeting. While this is not a big part of our results, we did run mini evaluation to consider these factors. To give an overview, we found age, VR experience, use of hand, and use of haptic feedback to influence the detection of haptic retargeting. However, we find gender, vision, and height to have no effect on detecting haptic retargeting. We believe these factors are worthy of exploration for future work. Overall, we believe our results are important to complete the knowledge of the potential space of haptic retargeting. Thus, we hope our work inspires future VR applications to leverage haptic retargeting in creating immersive and interactive VR experiences. And that wraps up my presentation. I'll leave my contact details in this slide. I'm happy to chat for questions, and since I'm finishing my PhD soon, I'm also looking for a job now. Thank you.